Hi and welcome to another video. In one of the previous videos we had a look at the gravity simulation and the simulation interface. Today let's have a look in another kind of simulation or implementation of the simulation interface, which is a spring simulation. Currently we have autumn and it would be really nice to simulate spring, however that's not something that we will be doing today. Therefore let's go for a moment to my painter over here. The spring that we will be actually working with is something like this, that you may have seen in the car suspension or so on. And in case of its simulation itself, we will be simulating a point that would be attached over here to the end of this spring. So looking at this simulation class over here, they say that it models a particle attached to a spring that follows Hooke's laws. In case you would be interested to know how the Hooke's law work, and that is basically an empirical law which states that the force needed to expand or compress a spring by some distance scales linearly, with respect to that distance, that is, that F equals kx, where k is a constant factor characteristic of the spring, for example stiffness, and x is small compound, to the total possible deformation of the spring. And this variables basically is something we can play with later when working with the simulation over here. So the spring simulation takes a couple of arguments. We have the start point, end point velocity like in the gravity simulation, but more importantly here we have this spring description. And spring description comes with mass of the spring, so the way that the spring is expanding and compressing it depends on the mass. Then also stiffness that we've seen already on Wikipedia mentioned, and there is this damping factor as well. So these are the three variables that we can work with in order to make the spring compress and extend differently. Here is my Flutter Playground application, and I've modified a little bit our example for the gravity simulation. So still we have this green box on the black background, but I've also added this little chart over here which shows the characteristics of our simulation. In the code over here, we have my app state as we did before, but now our simulation is a spring simulation and not a gravity simulation, and you can see that I have this spring description over here. Currently I have set mass to 0,1, stiffness to 15 and damping to 3. Let's run it again. There we go. This is what happens. So the green box, it actually worked a little bit like in the gravity simulation that we've seen before. So it looked like it accelerated as it was going down. And you can see this on my chart over here in the corner, that basically it started really quickly and then it slowed down and it ended the animation over here. If we reduce stiffness by a little bit right now, so let's say that stiffness will be 3 instead. Let's rerun it. Notice what happened. The animation got longer, and you can see it also on the graph that it wasn't as rapid to start with. So we also started quickly and then we just slowly ended to expand this spring to the end. But a typical spring can be expanded, and then when it compresses it can bounce up and down. In my case, notice that my start point is 0 and my end point is basically where I want to finish. So I want this spring to start from 0 and expand it to half of my screen basically, because it's over here, height divided by 2. So now let's just change this damping into 0,1 instead. Let's rerun it and notice what happens this time. So the lower damping is, the more we get our spring to just bounce up and down, and very slowly, almost up to infinity, it's just getting smaller and smaller bounces. It's almost like a sinusoid. If we would put it there like even smaller, let's say 0,001, then basically we are getting here a sine wave right now. Okay, but how about we make it something like 0.4? Let's see how it will look like. There we go, it's better. We know that at least at some point it will finish. So if we would have, for example, 0.8, then we get something like this. Okay, I guess you get my point with what damping does. So we've seen also what stiffness does, and we can now give it a little bit more mass. Let's say that it will be 0.5. And there you go. And we only get a couple of bounces right now. There are also here at the end, so the animation actually ends beyond my chart over here. So that means that there are a lot of small bounces here as well, and you can see what happens with this green box right now. So to summarize it, the more mass it will have, the less it will bounce. If we give it a 4.5 right now, then we get an animation where we just stretch our spring and that's it. It doesn't bounce at all. And the animation already finished over here. If you're interested how I drawn this graph over here, then have a look into my source code. But in short, I have here this custom painter that I've defined, and in the paint method I have canvas size, and then I'm drawing a couple of things. I'm drawing a rectangular over here, that is the background. Just keep in mind this is not optimized by any way, it's just for the purpose of this video over here. Then I'm drawing this line to mark like at the middle of the screen over here, and then we have a path basically. And here is the whole magic happening. So the simulation interface, as we've seen in the other video, it gives us access to this X, which gives us a position or gives us the current value of the simulation depending on time. In this for loop, I'm basically looping through X axis. So this is my X axis, and this will be our time here of the animation. And then also I have this T defined over here. And I'm also just in every pass of this loop just adding 0.1 to the time, because T is for time over here. And then over here I'm checking whether in this current time, so first 0, 0, then 0, 1, 0, 2, and so on, if the animation is finished. If yes, then I stop painting the line over here, the blue line. And otherwise I'm getting current position, current Y position on the screen. And then I also just make sure that we are not drawing outside of this gray box over here. And finally, I'm using path, and every time I'm basically adding a line to go to the next point on the next X on the path that we have. And that's it. That's how I'm drawing finally the path on the graph. Very simple, and it's all possible to simplicity of the simulation interface. I hope this video helped you understand maybe simulations a little more, or maybe it was just a good entertainment. Doesn't matter. Please subscribe, give me a like, and I'll see you the next time. But for now, I code you to death, and bye bye.